Welcome to LR circuits. What does R stand for? Resistor. What does L stand for? Yeah, that's good. Inductance, right? It's an inductor. So we have an inductor and a resistor. And this actually behaves a lot like something we've already seen. Okay? So if you have something that when you can charge and discharge, what else have we seen that looks like that? Capacitors, RC circuits, okay? Turns out LR circuits behave just like RC circuits. You can charge and discharge them. They have a time constant, okay? And today, actually, hopefully you didn't print the lab yet. If you did, I will print you a copy because I rewrote it. We're going to do RC circuits, and we're going to play with some oscilloscopes. Maybe you've used an oscilloscope before. Two of you. Good. How many of you are eventually going to take a circuits class? Okay, enough of you to make this worthwhile. So anytime you do any electronics, it's good to know what an oscilloscope is. It's the only way to really visually see what's going on in an AC circuit because you can actually plot the sine wave on the screen. So we're going to deal with that. This week we'll mostly just be doing some simple stuff. We'll make a simple graph. We'll start with the multimeters, which we're already familiar with. Then we'll move to the oscilloscope just to see what's going on with those. And then the last lab we'll spend a lot of time with oscilloscopes doing RC circuits, or RLC circuits, which is like, well, guess what's in an RLC circuit? Capacitors, inductors, and resistors, RLC. So we got RC, we got LR, we got LC, we got every manner of combinations. It also turns out that with AC circuits, right, when you have an AC input, RC circuits work as filters. So you can filter out high or low frequency. And why might that be useful?
Static or
control the signal, limit things that you don't want.
Let's think about what about surround sound? Which speakers like which frequencies?
I don't know anything about speakers.
Yeah, the tweeters. What do those have? Yeah, higher pitch, right? So your tweeters, right? Those are going to have higher frequencies. Where do you put the low frequencies? Your sub, right? So if you have music signals coming in, right? If you have frequencies coming in that are for TV sound or music, and you have a surround sound system, you might want to filter the high and low frequencies and send them to different places. So that's a really good way to use an RC circuit in AC. Instead of in DC, it's just a decay, right? But in AC, one side's going to send the high frequencies out, the other side's going to send the low frequencies out. So it does have some good applications. Anyway, back to LR circuits, which work basically the same way. Here you can charge them up by connecting it to a battery, then you can get rid of the battery, okay? And when you get rid of the battery, you get something that looks like this. Now this should look awfully familiar, okay? It's an exponential decay. And this is the current, so this is a discharge, or actually charging or discharging, you'll get the same thing because remember current looks the same for both for RC circuits as well. And then, this is discharging, sorry. And this is charging. Yeah. So discharging, charging. Yes?
I was just curious on the other slide. Is that always true that the 37% at 2 torque and
yeah, and why 37%? So this is at the time constant, tau. Okay? In this case, the time constant is L over R. In the RC circuits, the time constant is RC. Okay? The time constant is a time in seconds. So the time constant is when you get initial current times e to the what?
Oh, tau.
Tau, right? So if t is tau, then it's tau over tau. That's 1. So e to the negative 1 gives you 0.37. Okay, so that's why at the time constant, it's always dropped 37%. Because it's when time is equal to the time constant, that's going to give you e to the negative 1. Okay, so 1 over e is your first time constant, right? 2 over e is the next one. Okay? Yeah. Cool. Wait, 1 over square root of e? E to the negative, no, e to the negative 2. So 1 over, 1 over
Negative
e
half,
squared.
right?
Anyway, you just plug it into a
Negative.
It's hard to do in my head. All right. So yeah, discharging. This is charging. So when you're discharging, right, you start with a current. So this is this situation. When you're just hooked up here, you start with an initial current and it goes to 0. Okay. When you're charging, it starts with 0 current. Okay, because as you turn on the current, this thing resists it pretty strongly because you have a big change. And then your current starts to flow. It resists it a little bit less, until you get up to the full current, as if the inductor's not even there. And once the current's steady, what does the inductor do? When your current's not changing, how does an inductor, how does a coil of wire behave?
Like a wire.
Like a regular wire, okay? The only time you get inductance is if your current is changing with time. So while your current's increasing or decreasing, the inductor does something. Once your current becomes constant, whether it's the maximum current or 0, right, your inductor acts like a regular wire. Remember, inductors only care about changing current, right, changing flux. All right, here's a question. Okay. So we'll discuss a little bit again. Okay. Oh. All right. So, how does an inductor work? When you flip this switch closed, right? What's happening to the current? It should be increasing, right? So that, what does this do? Resist. Is it a big increase?
No.
Yeah.
So you're going from 0 volts, right,
Some
to
current.
this to 10 volts. So you have a large jump in what it's trying to do. This thing should put up a big resistance because it's a fast change. Okay? So initially, when we look at the charging version, what's the current? 0. Okay, so you start with 0 current. It resists it pretty strongly at first, but then it goes up to what current?
2 amps.
2 amps. Why 2 amps?
Because it's volts over the resistor.
Yeah, because once you get to the maximum current, this just acts like a wire. Now you just have a series circuit with a battery and a resistor, and you use Ohm's law. Okay, so you go from 0 current up to 2 amps. Good job. All right. Now we answered it. But go ahead. Yay. Okay. So yeah, we go from 0 to 2 amps. Okay. All right.